Section 6. This is our last section of the chapter.
We're not taking the quiz?
Nope, we're going to take the quiz later. So, Section 6, we're going to combine two things together. Now, a couple days ago, we talked about dice, so we're going to kind of come back to dice today. Whenever we're dealing with dice, we're going to assume we're talking, John, about a six-sided die. Normal six-sided die. Independent events versus dependent events. Okay, that's the main idea today. All of you are considered by your parents when they fill out a tax form as dependents. You are dependents because you are dependent upon your parents to provide for you clothes and food and shelter and those kind of things. Your parents are providing for you. That is why you are called dependents. So depending on what they do, depends on what you can do. At some point, you're going to graduate from college, maybe and move out, and you're going to become what? Independent. Then your parents are not going to provide those kinds of things generally for you anymore. So independent events can happen no matter what happens. But dependent events are conditional. So as we look at this, we're going to get back to what this is up here at the top in a little bit, but independent events, we multiply, and dependent events, we have to consider the first thing already happening. And let me explain what that means. We have these two dice. One's red and one's blue. You roll the red die. Okay, how many sides on the die? 6 sides. Of those 6 sides, how many of them have 4s on them? One side has a 4, right? So the chance of you rolling a red die that has a 4 on it is 1 out of 6. Really straightforward. That's what we did before. Now, how many odd numbers on the blue die? 3. So the chance of you rolling an odd number on the blue die is 1/2. So those are just very simple examples of independent events. It had no bearing on what happened before. Does the fact that you rolled a 4 on the red have anything to do with the fact you rolled an odd on the blue? No, so they're independent of each other, true? Okay. So, now, I take both die at once. The chance that I rolled the red 4 was a 1/6. The chance that I rolled that odd was 1/2. What's the chance I roll them together and I get both of those things happening? First of all, what's the chance you're going to get a red die? Only how many times? Only 1 out of 6 times am I going to get a red 4. So I got to roll that red die 6 times to get a red 4. Now, on the one time I get a red 4, I'm hoping to roll the blue die and get what? An odd. So the probability of getting both the red 4, which is 1/6, and the blue odd, which is 1/2, we multiply the fractions together. When you multiply the fractions together, what do you get? 1/12. So is it likely that that's going to happen? Probably not. Okay? So, as we're working on that, we have to understand that kind of probability. Will that help? Moving down. Independent events. The chance that we're going to get 2 reds really means we have all these markers. What's the chance we're going to pull out? Well, we have a total of how many markers? 6 markers. So let's see if we actually have this. I got a black. I got a red. We need some more. 2 reds. How many blacks are we supposed to have? 3? Any blues? All right, so here's our markers. So I come up here and I say, what's the chance that when he pulls a marker, he's going to pull a black marker? 3 out of 6. So close your eyes. Pull a marker. Okay. Yes. So, did he get a black marker? No. But that's very much in the probability. If we did that a bunch of times, on the average, it would be 3 out of 6 times he'd pull a black marker. But in this case, he didn't. Not the end of the world. But here, the chance that we pull 2 reds means he pulls 1 marker and gets a red, and then he pulls another marker and gets another red. Now, the fact that they're independent means we are replacing the markers each time. So, we come back to our markers. What's the chance that I pull a red out of these markers? 2 out of 6. So, the chance that you pull 1 red is 2 out of 6. So, I pull the red. Now, the fact that they're independent events means we replace the red back in. Okay? And now what's the chance to pull the red again? Once again, it's 2 out of 6. And as you said, Nate, what is the probability when you multiply those two? 4 out of 36. Use your calculator to reduce if you need to. And that's 1/9. So the chance that Justin were to pull 2 reds in a row is only going to happen 1 out of 9 times, even though 2 out of 6 of them are red. That is called independent. That means you replace it back in. Let's say it's midnight and you're trying to get dressed for an all-night capture the flag thing. And in your drawer, you have socks. And some of them are black socks and some of them are white socks. You want the black socks, right? But what's the problem? The lights are out, you can't see, you got to pull these socks out. Okay? So you pull the sock out, walk out because you don't want to wake up your little brother, and you look out in the hallway. It's black. Are you going to put that sock back in before you get another one? No, you're going to pull out another sock, right? That's not independent because you didn't put it back. That's called dependent. We're going to talk about that difference. Here, we're putting the marker back in, and then we're pulling again. So you're looking for keywords, and the word you're looking for is with replacement. That's your key word. Okay, let's do our statistics in here. How many guys do we have? 2, 4, 6, 8, 10, 12, 14, 16, 18 guys. And total, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 25 total people. Okay, so we pick someone at random. Okay, we go to the seating chart and we put our finger on the seating chart at random. Here we go. I go right there. It lands on Caroline. Okay? What's the chance that I was going to pick a guy there? 18 out of 25. But I didn't. So I happened to fall on that other 7 out of 25 part. Remember, that's called the what? Not the guys is called the what? What's that word for it? Starts with a C. Ends with complement. Complement. Remember that idea? The not thing happening. So the chance of picking a guy is 18 out of 25. So the guy leaves. Fine, great. He runs an errand. He comes back the next day. Same thing happens. We want to pick someone at random to go deliver something to the front office. What's the chance we pick a guy again? 18 out of 25. So get out your calculators. Multiply 18 times 25 over 25 times 18 over 25 and tell me what you get. Should be around, I think, 324 over 625, but please check me on that. Is that right? Yeah. Okay, so that's our probability of getting that. Now, it might be hard to understand that probability, so would you turn that into a percent for me? Divide it out and multiply it by 100 and tell me what that is as a percent to the nearest tenth. Exactly? 51.84. So let's say 51.8. For me to say 324 over 625, that's kind of a big number. It's hard to get your hands around. But if I say the chance of that happening is 51%, does that make more sense? Approximately how often is it going to happen? About half the time. We're going to get a guy picked 2 days in a row. But is there more than half that number of guys? Yeah. We have a predominant number of guys in this class. Now it's interesting, I've been doing these same statistics for the last couple days. In my third hour class, it's almost perfectly switched. The ladies are 2/3 majority and the guys are 1/3 majority. And so that's because of schedules. Somehow, what's the chance that this would happen? When Mrs. Vishnoff brings people into the school, do you think she brings them in 2/3, 1/3? No, what's she shooting for guys to gals? Probably half to half, right? So as she's working through that, we have to keep that in consideration.